Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss how to delete first node in a doubly linked list in Java. So friends, let's suppose we are given a doubly linked list having 3 nodes, say 1, 10, 15. And if you see below is the algorithm to delete the first node in a doubly linked list. So friends, as you know that in doubly linked list, head points to the first node and tail points to the last node. So in order to delete the first node in a doubly linked list, we usually manipulate the head pointer, and if you see as tail points to the last node in a doubly linked list, therefore tail node doesn't play any much role in deletion of the first node. But there is a case where tail nodes comes into picture when there is only a single node. So if a doubly linked list contains only one node, then head and tail node both points to that particular node. Therefore the tail node comes into picture because we need to delete that particular single node. So the only place where tail node comes into picture when head is equal to tail. That is, the doubly linked list has only one node and both head and tail points to it. So we'll see the demonstration of this algorithm step by step. So suppose we need to delete the first node. So in the algorithm, first step would be we need to check whether the list is empty or not. So if the list is empty, it means there is no node to delete. Therefore, we may throw no such element exception. So if we take above example, then this doubly linked list has 3 nodes. Therefore the doubly linked list is not empty. So the condition in if statement comes out to be false. So the first step would be we need to create a temporary node which will point to head. As we want to delete the first node, then we will create a temporary node which will point to the head. Moving ahead. Now we'll check whether head is equal to tail or not. So currently head points to the first node and the tail points to the third node. Therefore they are not equal. So the condition comes out to be false. And the if part will be executed. So friends, we need to remove this first node now. So in order to delete this first node from the doubly linked list, we need to do two things. First we need to break this next pointer which is pointed by the temporary node. So if you see temp next points to the second node, so we need to remove this, and if you see second node points back to temporary node and we need to break this link. So these two links we need to break. So in the else part, we'll first break the link which is pointed by the second node to the temporary node. So in order to break this link, we know that head points to this first node which we want to remove and its next points to the second node. So here what we'll do, we'll say head dot next. So when we do head dot next, we reach to the second node, and if we do dot previous, then this is the link. So currently this previous points to the first node, and when we assign null, so this link breaks up. So it would be something like this. So what we are doing in this line is we are traversing from head to its next and then to its previous. So from head we traverse to its next node and then we traverse back to previous. So we broke this link here and we assigned a null value to it. So we removed one link. Moving ahead. So friends, now we know the temporary node points to head, which is the first node which we want to delete. Therefore once the first node is removed, head will be pointing to the second node, because after its removal, second node will become our new head. Therefore we need to traverse this head to its next node. So to head will assign the value of head dot next. So currently head points to the node which we want to delete and head next points to the second node. And once this node is removed, we know that now head will point to the second node because second node becomes the head of the doubly linked list. So in order to do that, we need to traverse head to its next position by assigning head dot next value to head. So it would look something like this. Moving ahead. And we know that temporary node refers to second node. So we need to break this link as well. So to break this link, we'll simply do temp.next equals null. So temp.next point to second node and we'll assign a null value to it. So it would look something like this. So now as you see, temporary node is an individual node where previous points to null and next points to null. So in the last step, we'll simply return the temp because this is the first node which we deleted. So friends, now W linked list contains two nodes where head points to the first node and tail points to the second node. Now suppose if we again call this algorithm to delete the first node, then it would be something like, first we will check whether list is empty. So list is not empty. So friends, we'll create one temporary variable which will point to head. And as we know that head points to the first node of a W linked list, therefore in order to delete this first node, we'll point the temporary node to the head. Moving ahead, we'll check whether head is equal to tail or not. So head is not equal to tail because head points to first node, tail points to the second node. So the else part will be executed. Now here we'll do the same thing. We'll first break this previous link which is pointed by the second node to the first node. So in order to reach this node, we'll use head.next, and to assign null value to previous, we'll use head.next.previous. So when we'll do head.next, we reach here, and when we'll do dot previous, this is the link, and we'll assign a null value to it. So it would look something like this. Now we have removed one link. Moving ahead, and now we'll simply traverse head to its next node. Now once this node is removed, we know that head should point to the next node in the W linked list because now that node will become our new head. So we'll simply traverse head to its next position by assigning head.next value to head. Moving ahead, and we'll simply assign a null value to temp.next because we need to remove this link as well. So now temp.next points to null. And in the last step, we'll simply return the deleted node. So friends, now you see W linked list has only one node where head and tail both points to that particular node. So when we will call this below algorithm again to delete the first node, then first it will be checked that whether the list is empty or not. So currently list has one node, therefore it's not empty. Then we'll create a temporary node which will be pointing to head because head points to the first node in the W linked list. Moving ahead, we will check whether head is equal to tail or not. So currently if you see, head and tail both points to that particular node, therefore they are equal. So the condition in if statement comes out to be true, therefore if block will be executed. So friend, this is the only node left in the W linked list and we want to remove that. Therefore we need to remove this both pointers head and tail because they are referring to this node. So in the first step, we'll assign a null value to tail. So it would look something like this. So now tail would be pointing to null. And then we'll simply assign head.next value to head. So it simply means we are assigning null value to head. So now head will be pointing to null. And we'll simply assign null value to temp.next. But if you see, temp.next is pointing to null value only. Therefore, we just simply return the temporary node in the last step. So friends, you saw there was only one node remaining and we removed that node as well. Now if you see, tail and head both points to null. So if we call this algorithm again, so it will be checked whether list is empty or not. So if you see, head and tail both points to null, therefore the W linked list is empty. Therefore if we call this algorithm, then an exception will be thrown. So we can throw an exception saying that there is no such element left. So friends, this was the demonstration of the algorithm. Now let's go to Eclipse and see the working code. So friends, in my previous tutorial, I created one class by name WLinkList and we implemented the WLinkList into that class. So this class has basically a head node and a tail node and an integer variable by name length which stores the size of the WLinkList. You can watch my previous tutorials to understand those concepts. So in this tutorial, we'll just code a method which will delete the first node in a doubly linked list. So I'll create a method as public list node delete first. Now this method will return us back the deleted node. So the return type is list node. So first we'll provide a if check, and in if block we'll provide a condition as whether doubly linked list is empty or not. So if doubly linked list is empty, we'll throw an exception. Moving ahead, then we'll create a list node by name temp, and we'll assign a value of head to it. As head points to the first node of a doubly linked list, therefore we'll assign value of head to this temporary node, and then we'll check if head is equal to tail or not. So when head is equal to tail, it means doubly linked list has only one node. So in that case, we'll assign null to tail, because we need to break the reference of tail pointing to that particular node which we want to delete. And if head is not equal to tail, then in else block we'll write head dot next dot previous, and we'll assign a null value to it. We are assigning a null value to head dot next dot previous because we need to break the previous link which is coming from the second node, and then we'll simply assign head dot next value to head. Now we also need to break the next link which temporary node is pointing to the second node. Therefore we'll do temp dot next and assign a null value to it. And finally this temporary node is removed. Therefore we know that size of length is reduced by 1. Therefore we'll do length. So here we are decrementing the length by 1 because we have removed one node, and in the last step we'll simply return the temporary node because this temporary node is pointing to the first node of doubly linked list. So friends, this is the algorithm to remove the first node in a doubly linked list. Now let's test its working. So friends, in my previous tutorial we saw how to insert the nodes in doubly linked list. So here I have added 3 nodes by data as 1, 10 and 15, and if I print the doubly linked list in the forward direction, so you can see 1 points to 10, 10 points to 15 and 15 points to null. So totally there are 3 nodes. Now let's delete the first node in the doubly linked list. So we'll call delete first, and let's display the doubly linked list again. So I'll call display forward, and if I run the code, so you see initially doubly linked list had nodes as 1, 10 and 15, and the node having data as 1 was the first node. So when we called delete first, the node at first place got removed and the doubly linked list became 10, 15. Now let's say I again call delete first, and if I run the program, so you see when delete first was called first time, 1 was removed, and when we called delete first again, so 10 was removed because 10 became our new head. And finally if I call delete first again and I run the program, so you see all the nodes are removed and nothing got printed because in display forward we have kept a condition, if head is null then simply return. So when all the 3 nodes got removed, head pointed to null and nothing was printed. But if I call delete first again, as head and tail both are pointing to null, and if I call delete first again, so you can see we are getting an exception as no such element exception because list is empty and there is no element left to be removed. So friends, this was the tutorial to remove the first node in a doubly linked list. I hope you like this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.